Hi, it's Professor Adam. Let's talk about Lewis dot structures. We've learned about ionic bonds with full electron transfer between atoms before. But another way atoms can form molecules is by sharing electrons in a covalent bond. To understand these, we first need to learn about Lewis dot structures. In a Lewis dot structure, we represent a molecule by its chemical symbol such as H for hydrogen, C for carbon, F for fluorine, and so on. With carbon and other small simple atoms in Lewis dot theory, it is assumed that there are four bonding sites where the valence electrons can be drawn. Carbon has the electronic configuration 1s2, 2s2, 2p2, and so has four valence electrons which we can draw as small dots or circles in each of the bonding sites. Putting two electrons in one bonding site before all are filled is incorrect in Lewis dot theory. By filling up these sites with 2 electrons each, carbon can have 8 valence electrons, filling its octet. To draw a Lewis structure for a molecule, first draw each atom with its symbol and valence electrons. The unpaired electrons on each atom can then form a covalent bond which contains 2 electrons. To show that this is a covalent bond, we draw a line rather than show the 2 dots. In this case, we will assume that all electrons are paired, and so we will draw them explicitly in lone pairs. The number of valence electrons that an atom has determines the number of bonds that it can form. Carbon has 4 valence electrons and needs 4 more to fill its octet, and so likes to form 4 covalent bonds. Nitrogen has 5 valence electrons, 3 short of a full octet, and thus likes to form 3 covalent bonds. Oxygen, with its 6 valence electrons, needs 2 more and often forms 2 covalent bonds, whilst chlorine has 7, one less than a full octet, and will usually form 1 covalent bond. Owing to having the same number of valence electrons, atoms in the same group usually have the same Lewis structure. We can see this in group 4. For carbon, silicon, germanium, tin, and lead, they all have 4 valence electrons and will typically form 4 covalent bonds. One covalent bond between 2 atomic centers sharing 2 electrons is called a sigma bond and is sometimes called a 2-center 2-electron bond, or 2C, 2E for short. Molecules are not limited to only sigma bonds and can share many more electrons and form double or even triple bonds. Take carbon dioxide for example. After we form the first covalent bond, there are still unpaired electrons. Because there are unpaired electrons on both carbon and oxygen, these unpaired electrons can form another covalent bond. The bond formed using this second pair of electrons is called a pi bond. Triple bonds can also be formed as shown here. The first bond is a sigma bond, and the second and third bonds are pi bonds. Triple bonds tend to be shorter than double bonds, which are shorter than single bonds. As we increase the number of bonds and electrons between 2 centers, they are pulled closer together so that triple bonds are shorter than double bonds, which are shorter than single bonds. Sometimes atoms share more electrons than their valence would typically have, and thus are given a formal charge. Such a case is in ammonia when it shares its lone pair of electrons with another hydrogen atom. In ammonia, the central N atom shares 3 electrons to form 3 NH bonds with the other 2 as a lone pair. In the ammonium ion, the nitrogen contributes 4 electrons to the Lewis dot structure as one is taken by the hydrogen to form the bond. This means that there is a deficiency of 1 electron and gives the ammonium ion its +1 charge. Since there is more than one atom involved in the ion, we call this a polyatomic ion. Many atoms typically have a preferred or common valency state. Hydrogen, for example, only needs to fill its N is equal to 1 shell and only wants to have 2 electrons. Carbon, nitrogen, oxygen, and fluorine want to fill their N is equal to 2 shell which means filling the octet with 8 electrons. Larger atoms, such as phosphorus and sulfur, can have 5 or even 6 bonds, meaning their valence can accommodate more than 8 electrons. Let's check comprehension.